Let's use the normal distribution to approximate the binomial distribution. It's expected that 25% of students enrolling in a history course will earn an A. Approximate the binomial distribution with the normal distribution and find the probability that of 500 randomly selected students taking history, more than 150 will earn an A. Well, let's just first start with what we know. So I know the sample size is 500. I know my probability is 25%, so let's throw that in there. If probability is 25%, then 1 minus P is going to be 75%. Well, what does that give me? Well, because we're trying to use the normal distribution to approximate the binomial, I need to make sure that NP and N times 1 minus P are both greater than 5. So N times P, 125, I'd say that's greater than 5. And then N times 1 minus P. Boom, they're both greater than 5. So this is fine and it's going to work. So now we need to find the mean and the standard deviation so that we can use our normal distribution. Well, the mean is N times P. So we already know that, but just for fun, we're going to do it again. And the standard deviation is the square root of N times P times 1 minus P. And there's my standard deviation. Okay, so now that I have all of my pieces, let's go and look at more than 150 will earn an A. Okay, so let's think about the normal distribution. We know that the mean is in the middle, right? So that's the 125, and we're talking about 150. Okay, so 150 is going to be somewhere over here. And with the binomial distribution, we think of it kind of as a rectangle. So this whole thing here is 150. Just pretend that that says 150. Now, when I'm looking at the right side of this is 150.5. And the leftmost piece is 149.5. Okay, well, now we got to look at what we're given. We want more than 150. That means 150 is not included. So we're going to use this piece and go to the right. Okay. Now, normally when we find probability with the normal distribution, whatever we're working with gives us area to the left. So we're going to need 1 minus whatever we're doing. Okay. All right. So let's do this. We are going to take 1 minus the normal distribution. You can see it starts with X. Well, we know our X value is 150.5. comma, the mean. I can just click on 125 there. And then our standard deviation is in B10. And then do we have a cumulative distributed function or a probability mass function? Well, we're dealing with we want it to be true, the distribution function here. So we type in a 1, and that gives us 0.0042239, meaning the probability that more than 150 students will earn an A is like 0.4%. It is very, very, very small. And we can kind of see that based off the picture we drew, right? Like we know that if this is the mean, and our standard deviation, let's just say it's 10, 135, 145, 150 is more than 2 standard deviations away. So we already know that that's really a small value and probably just not going to happen. So you have to really pay attention to what does it say? Is that number included? Which side are you using? So on and so forth. If you wanted to, let's just say we wanted to do between, or exactly, let's do exactly 150. Okay, so let's say we want to know the probability of exactly 150 students. So thinking through that, that means we want, we're gonna have to subtract, right? Because we want just the area between the 149.5 and 150.5. So I would say, okay, I'm going to take my normal distribution of 150.5. I'm going to do the mean, standard deviation 1, and I'm going to subtract the normal distribution for 149.5, comma, mean, comma, standard deviation, comma, 1. And you can see that it's a 0.14735% probability of exactly 150. So depending on what you need, you use the same idea and the same concepts of doing all this by hand. Sometimes, really most of the time, I think a picture helps a lot because you can visualize what you need, and that will allow you to really understand what values you need to use. when using the normal distribution to approximate the binomial.